Hello, I'm Craig Rodgers. I'm a solutions architect. You can find me on Twitter at CraigRodgersMS, on my blog, craigrodgers.co.uk, and also on LinkedIn. And this is part of a Tech Field Day showcase. And I've titled this Intel and CXL, the future of server architecture. I'm going to look at a few things here. You'll see that it kind of leads into the future, where we're going with server architecture. And this is off the back of a paper that I co-authored, Digital Infrastructure at Datacenter Scale. It's all about the ecosystem, and it's very interesting what's happening right now with the shift and the direction that things are going. If we look at the drivers that we've seen, within the hardware ecosystem, what's been driving the growth, what's been driving the direction, or certainly over the last decade, and it's been cloud adoption. The hyperscalers have really, they've built these massive estates of servers, huge numbers, more than companies. It's been staggering, the level of adoption. And in order, at that scale, they have to make, as Arthur alluded to, marginal gains to further drive efficiency. And now they've become such a scale that they're starting to work together to steer things down that common route, and that's where CXL, that we're going to touch on later, will really come into play. So server architecture, most of the workloads that are running out there right now are likely running on a second or third generation Intel Xeon processor, scalable Xeon processor. And there's actually been a lot of limitations around the amount of bandwidth addressable to devices and peripherals. PCI Express Generation 3 came in 2012, and it's only with Ice Lake CPUs there in 2021 that we've seen that jump to PCI Express Generation 4. So what was 16 lanes of performance in Generation 3 is now only 8 lanes of performance at Generation 4, which is doubled the effective throughput, and this is getting put to better and better use as both previous presenters, Al and Arthur, have alluded to. Accelerators have really, they're really shining a light and affecting how workloads are positioned. There's current inefficiencies in delivering these things at scale. It's being done very well at the moment. We've had VMware for many, many years making the best possible use of RAM inside a host, of CPU inside a host, of network throughput inside a host. But the boundaries for these efficiencies have been largely within the host, except for storage, obviously, with external storage arrays. But if you wanted to size something, the likes of an Arthur's perfect configuration, you would have to size the amount of RAM that you needed, along with the amount of persistent memory using Optane. And as we've alluded to there with Optane, we know it's been recently cancelled. However, the concept of persistent memory will not be going away. It simply won't. It's added a lot of value and delivers performance and capabilities and scale that simply weren't there before. So we have a number of large companies now that have worked together to devise CXL, and a lot of this was spearheaded by Intel, and there's now north of 150 contributors who are all signed up and agreed to use this technology. CXL is going to transform the future of server architecture. So if we look at the bottom there on this diagram, we're looking at a die, and as we move up in that diagram, throughput will reduce, but latency will increase. So the most potential gains The largest gains that we can see are at the die level and bringing that into the bigger picture. It's also going to bring capabilities that we simply haven't had. CXL is going to allow us to pull memory, and in future revisions will even allow CXL switching. So if you think about it as on your corporate network, you have devices that say plug into a 1 gigabit switch. You only have perhaps 1 gigabit external bandwidth, but all of your users have 1 gigabit of connectivity within the network. CXL switching is going to deliver that capability on the PCI Express bus. You'll be able to uplink, if you will, to additional resources that can talk to each other at fast speeds within that CXL switch, but only have a certain amount of upload bandwidth, if you will, to the rest of the host. This is opening up a new level of consolidation that we haven't had available before. So you can now specify a server with a virtual server or a physical server with a smaller amount of RAM and not be bound by the limitations of the amount of RAM actually installed within that physical host. And that is going to lead to a completely new era of efficiencies, driving scale. The hyperscalers will absolutely benefit from this, and larger companies as well, people with multiple data centers. On the lower end, it may not affect you, but on continued cloud adoption, you will have now options of, do you need fast RAM directly attached to the host, or do you need RAM that is available through a CXL bus? So it's going to open up additional optimizations in that, do you need, we have the same at the minute with SSDs. Do you need a capacity level SSD with a certain level of performance, or do you need an NVMe SSD with multiple times the performance? We're going to have that option soon with RAM and other peripherals. And this concept of CXL switching it's just going to open up so many new possibilities, and there'll be some of them that we don't even realize yet. As with any technology adoption, having that external interface is going to allow us to disaggregate much better in the future than we currently can. We've already seen certain levels of disaggregation within the storage industry, say vast data, who can disaggregate performance from capacity. But now we're going to be able to disaggregate across everything within the CXL bus.
I briefly read about CXL, and it seemed kind of amazing, but also like one of those technologies that this is going to take forever to roll out. So where are we in terms of what is available today, what's coming soon, and what sort of, distant future stretch goals?
Great question, Ned. I myself would have been in a similar position to you a couple of months ago. However, having to write this paper, I will contribute to writing this paper. You have to obviously read up on something a lot more, and my mind has been absolutely blown by the capabilities of CXL. CXL 1, the standard, was released in 2019. We will not be able to use it in a server until Sapphire Rapids, and I'll touch on that shortly after this. However, CXL 3 standard, we have 1, 1.0, 2, and 3.0 was actually released there a couple of weeks ago by the time this video was released. And the current trends are, we have vendors who are all committed to using them. Samsung recently released specifications on a new SSD drive. Obviously, processors, Intel and AMD and ARM, are all going to support using this bus. So the vendor level support is there, and obviously for them to release products that take advantage of this technology, they need time to develop, test, retest, fix bugs, retest, and bring those to market. What surprised me on my research on CXL was just how widely this is going to be adopted. We're going to start the cadence of releases here on information regarding new products. It is going to be staggering.
You mentioned version 2 and version 3, even though we can't use version 1 yet because the hardware is not there.
Correct.
Will those new versions, like version 3, require different hardware than what's currently being developed, or is this more of a it'll be baked into a firmware upgrade at some point?
Firmware upgrades are actually part of the CXL standard, and in the same sense of moving from Skylake to Ice Lake, PCI Express 3 to PCI Express 4, you will need a new platform for CXL when it comes. Now, the easiest way to consider CXL is this. We've been using PCI Express 3 from 2012 through to 21. PCI Express 4 has come on the market and has doubled the performance of 3. CXL 5 is essentially PCI Express 5 with additional benefits. It's the easiest way to consume it. It uses the same electrical interface, the same physical connector as PCI Express. It's essentially a better version of PCI Express. So anytime you want to move to a newer version of CXL, you will have to update the underlying platform. Now, they have thought about this a bit, and if you invest in CXL external peripherals now, such as a module that provides you with lots of RAM or lots of persistent memory, given the lifetime that Arthur alluded to in his presentation, a CXL 1.1 device will be able to connect to CXL2, CXL3. So it's like a rack level network, if you will. That's the concept here behind CXL. It's a network within the rack that lets you go, right, it's not just now, I need 16 servers with this amount of NVMe, this amount of SSD, this amount of RAM, these number of cores. It's perhaps I need 10 servers and this amount of persistent memory and this amount of additional DRAM that I'd like to be able to move between hosts, and whatever else accelerators end up adopting this interface. And I think it's a case of if you build it, they will come, and this is, I believe they will come.
What you're kind of blowing my mind a little bit here when I think about it, because you mentioned memory, but also GPUs and other accelerator types that are going to be part of this fabric. When I think about like the bin packing challenge that especially hyperscalers have to do, there's a reason why they have these different families of virtual machines with very specific and prescriptive number of CPUs and memory. It's because that packs the best onto the hardware they're using underneath.
Absolutely.
This completely blows that model away, because now it's more the way that they deal with storage, which is there's a certain amount of storage performance, but you can layer in as much storage as you want for one of those virtual machines until you hit the interface limit. That's more what we're going to be looking at now, is you can pack as much memory you want into that 2 CPU VM. It's going to be able to use it all efficiently.
I feel like it's taking a lot of the logical concepts that we're used to from like virtualization and containers and all that stuff, but it's bringing it down like the bare metal hardware, right?
Yeah.
Like,
yeah.
I don't care how many servers I have anymore. I have enough CPU, I have enough memory. Maybe I have 10 servers, but then I've got these extra memory accelerators to get there. Like, I just don't care anymore. I'll add another one. I'll do this. It doesn't become as constricting as I've picked this node of configuration with this much CPU, this much memory, and I'm locked into it now, at least for this, like, whatever design phase of my data center. And then, well, the next one I have to do this brick again, and then I'm stuck with these bricks until they age out, and then I can go to the next version, right? So this is kind of just like getting rid of all that stuff that makes it difficult.
Absolutely.
And if I can jump in as well, the thing is, and you have a bullet point down there for that, but disaggregation. So maybe I'm putting the
I know we're getting a little ahead of it. It's too exciting.
I mean,
Can't help it.
There was this Gen Z project which kind of ended at some point because I don't know if it's CXL which took over. I don't remember at the time. But if you think about the next evolution, which is we may get to a point where you just get pools or arrays, whatever, just GPUs, just memory, just CPUs, whatever, and then you just go and you partition, slice it as you want. And I think that's really if that's going to happen, that's going to be really super exciting.
I'll pick that one up in a couple of slides. I'll pick that one up. That's exactly the direction this is going. I'm a solutions architect. I've worked in VDI. I've worked on VMware clusters, multi-site. For me, my insight here to researching for this paper, CXL, it's going to turn part of the solutions architecture world upside down. We're going to have to completely change our approach on how we size hosts. That boundary of the host no longer exists, and it's going to open up a whole plethora of additional workloads that we can do. Where, as Max alluded to there, a tray of GPUs, if you can power and cool them, yes, absolutely. However, we have there will be workloads here where, because it's all on the CXL bus, the GPU will be able to access the RAM directly on the tray of RAM. It doesn't even need to go to the host. It's thinking of these components now as a switched environment. That's the direction this is going. So I'll lead into persistent memory. Arthur and Al have both alluded to Optane. Obviously, I'm well aware as well of the recent news there that it's no longer going to be sold as Optane. But I took the weekend when I read the news, and it reminded me of the days going back to, do you remember you had PCI, and then AGP ports came, and we had dedicated ports for graphics accelerators, and then AGP was going, and we went to PCI Express. The only thing that changed there was the slot that you were plugging it into, and we gained additional capability. You lost a dedicated graphics port, but you gained performance, and other peripherals could use that same connection. That's essentially what we're getting here with the disappearance of Optane over time. We'll no longer be using DIMMs to access persistent memory. It'll be accessed through a PCI Express port. Also, if you look there at the bottom, we have obviously hard drives, very, very slow levels of access. And as we move up the rows in this, Optane fills, persistent memory fills a fantastic location there in terms of performance. I need more than NVMe, but I don't need RAM. But it can also function as RAM or storage. It's a very versatile product with a nice blend of performance. So when can we take advantage of this? Sapphire Rapids, it is going to be the platform that lets us use CXL. It's going to Sapphire Rapids is going to be the first here for a lot of things. It's going to be the first for DDR5 and high bandwidth memory. High bandwidth memory numbers are just are staggering. Hundreds of gigabytes per second on high bandwidth memory. PCI Express 5, but also CXL, the same port, can operate in two different modes. So it can, if you have a PCI Express 5 card, it can work in PCI Express mode, or it can work in CXL, and those could be auto-negotiated. We have enhanced virtualization capabilities around AMX, around the accelerated streaming accelerator. Sapphire Rapids is really going to bring about a huge amount of change here in how in completely it's going to turn server architecture upside down.
Is there the fact that we're moving from Optane to CXL? is it changing the way we use persistent memory in let's say more as a kind of a programming concept, as a way of storing data into memory pages, the way not as the use case that we usually see in infrastructure use cases for better density for VMs, but more in the sense of you really using persistent memory as a primary storage media somehow.
I'm not sure exactly on the methods that developers would use to access that, but I know that persistent memory is going to be treated the same way, just via a different bus. So it can be accessed as the RAM or as persistent storage. So it's just the variance there is the amount of bandwidth through to it via the CXL bus and the performance that it gives versus either NVMe storage or DRAM. I'll move on to the next slide and you'll see disaggregation is again back to these cloud providers and their drive for efficiency. I only want to have the exact number of cores that I need. I only want to have the exact amount of memory, the exact amount of storage. The emerging technology here is Sapphire Rapids, and the future will be the next generation. So CXL appliances and appliance expander pooling accelerators, that's providing the external access to that PCI Express 5 bus via CXL. In the future, when in CXL2, which will be based on PCI Express 6, that's when we really start to see the advantages here of CXL. Now, historically, we're all familiar with the cadence on release cycles here in terms of chipsets and processor generations. There's a big expectancy here that the cadence of release cycles is going to increase dramatically. It won't be 2012 through 2021 getting 9 years out of a PCI Express slot. It could be as low as 2 or 3. And and Intel recently said in an investor briefing that they spoke to customers and they wanted a new processor every year and a new platform every 2 years. And I imagine with CXL, we'll be seeing a cadence here of perhaps every 2 years based on that. There's another advantage here. When we think of this pooling of resources, memory, look at the components within a server. We have SSDs, they have their own DRAM. We have network cards and infrastructure processing units that have their own DRAM. We have graphics cards, GPUs, and other accelerators that have their own DRAM. Why do they have that? Because only they can access that RAM on that card quickly, and it's secure, and it's not meant to be shared. The shift now in the future is going to be that a hard drive will not ship with RAM, it'll use pooled memory. And a network card will not ship with DRAM, it'll use pooled memory. And you'll be able to decide how much RAM that is, because you could have a host that has no network traffic and the DRAM on those network cards is completely wasted. It's not being used at all. So now that shared pool of memory makes more efficient use of the total. It really is transformational. So in summary, PCI Express today, obviously, cacheable here is a big thing. One of the modes within CXL involves caching the RAM and maintaining coherence. So that means if the RAM is in an external housing, the CPU can cache that RAM effectively for the device that has been allocated to. If it's connected via a PCI Express bus, that won't be cacheable RAM. So that would be, for example, a network card with its own, say, 1 gig of DRAM cache. That won't be coherent. you can see there the challenges. It's all around efficiency and pooling memory. And CXL, also all CXL communications can all be secured and encrypted using AES encryption real time. And it's so these days security's a bit of a thing. Obviously everything has to be secure. And by the very nature of the fact that it's an open standard with 150 vendors on board, we know this is, that this is agreed on. This is definitely coming. Definitely coming.
I know you just touched on security real quick, and I know that's been a theme throughout all of our sessions today, right? Just kind of the things that Intel can do at the security level, because they can control the processor, the network card, storage, right? Everything when it becomes under the Intel ecosystem, there's a lot of wild stuff that can happen to make more secure. I think this is going to be great too for that too, right? I'm looking forward to all sorts of new things that we probably can't even fathom now with this kind of data access, but still making ourselves more secure and less likely to see things like, I don't know, I'm like sitting here thinking like, how would I exfiltrate data from this system? Like, I don't even know yet. That's going to be a rough one. I think there's a lot of potential here.
Yeah, if you have GPUs communicating via a CXL switch directly to a bank of RAM, so you're not capping at the amount of RAM on a GPU, it's the amount within an enclosure across multiple GPUs. You have no way to intercept that.
Exactly.
If that's switch traffic, it's so adding security is obviously been a concern for 150 vendors. Yeah.
Yeah, I was going to say, if you have these huge banks of memory that are sitting there, that's a prime target, right? Because they're not sitting inside the same server chassis and on that limited bus anymore. Now they're sitting on a bus that's accessible by multiple servers. So you have to make sure the segmentation on your memory bank is going to be really heavily. I don't know. It raises some security concerns.
But we can get into how is that actually distributed across the memory bank, right? Like how is it actually, the data actually distributed within the memory bank? So that might be just like, it doesn't matter. I mean, I'm looking forward to watch this evolve. I think there's a lot of potential.
Yeah, this is going to be super cool.
Yeah, and the other thing which comes to my mind is also in terms of reliability, when you were saying that some, SSDs and other components have their own inboard memory, the fact that you're kind of delegating or removing the layer and putting it somewhere else, then you kind of start thinking, what happens to my data? Do we need to put in place new kind of, data reliability, whatever algorithm, whatever, to make sure that the data is not lost when it's in transit, for example? I know that it's going to be at very, very fast speeds, but that's the thing which kind of hits my brain instantly almost,
Absolutely. So CXL has a fabric manager that controls what devices have access to what pooled resources. So if you have a tray of RAM with, say, 512 gig, you can say, I want 32 gig to each of these devices. And that in much the same way as network traffic is secured, you can the devices have the equivalent of a MAC address within the CXL network that isolates them as unique. So only this device can use or access these resources, and then they're also encrypted. So even if you did gain access to the shared pool of memory, you would only be able to decrypt and encrypt what you were entitled to see as well, because all our traffic's encrypted. It's fascinating stuff. So whenever we consider digital infrastructure at data center scale, which is conveniently the name of the white paper that we've co-wrote, CXL is actually going to let us bring components and security and servers and accelerators closer together, but give us more control, more visibility. All of this is going to be accessible via API. There'll be new tools that will come that'll provide greater insight and greater control. Intel One API is already going to let us perform a lot of these functions down the line. And whenever we look at data center scale, it's growing, it's getting bigger, and we know now that in future it's going to be much more disaggregated and let you choose different ways of doing things and not commit yourself to X number of hosts that all need licensing. You know, it's going to let you make better use of your money and your investment for the infrastructure that you're taking on.